Okay, so let's get started. So here's the problem. How much force is applied to a 950 kilogram car that is rear-ended, causing its speed to change from 20 to 22.5 meters per second during a 0.65 second collision? So first thing to do is to draw the diagram. And I say draw a before and an after drawing. So the before drawing is you have some car driving forward at 20 meters per second. And some car is going to rear-end it. So the way I like to draw my before and after is like this. You can do it however you want to, but I like to draw it like this to show the before and then the after. So then in the after, my car is hit and crinkled, we're assuming. And now it's going 22.5 meters per second, and it's hit by some other car behind it. He's crinkled too. Okay. And that's really all I can draw. I can't really draw time. I can label the velocity or the masses. So here's 950. Okay. So there's my drawing. Nothing too complicated. It took me a minute and a half. And you can do it in shorter amounts of time, I'm sure. So B, label the knowns and unknowns for the problem. So let's start with what we're solving for. So how much force? We're solving for F. How much force do we need? And then we go through what we know. We know that we have a mass of 950 kilograms. If I actually can write it correctly. Okay, so that's this number. It says it changes speed from 20 to 22.5. So my initial velocity, how fast it was going at the beginning, is 20. My final velocity, how fast it's going at the end, is 22.5. And the time of the collision, the delta t, is 0.65 seconds. Okay? So now we're ready to solve. So the equation I'm going to use is this one. F delta t equals delta p. Now, you might have a little bit of trouble with the setup at first, the first time you see it. So stick with me here. F is what I'm solving for, so I just write F here. Delta t is given in the problem. It's 0.65. You don't have to do a change. I'm going to give you what the change is. So all you have to do is put in the value for delta t, assuming you know it. This is where it gets tricky for people. So delta p. So remember that change in anything is final minus initial. So this is final momentum minus initial momentum. So before I can solve this problem, I need to find these two values. And I'm going to do that up here, but you could do it wherever. So momentum is equal to mass times velocity. So the final momentum is going to be the final mass, which never changed, it's 950, times the final velocity, which is 22.5. So 950 times 22.5 gives me a momentum of 21,375. Okay? My initial momentum is then going to be my mass times my initial velocity. So my mass is still 950 the whole time, but my initial velocity was 20. And when I multiply those two out, 1900. Well, I could have done that. Come on, self. Or, sorry, not 1900, 19,000. So now we're ready to plug those numbers down in here. So delta P is final minus initial. Here's my final, 21,375 minus my initial, which is 1900, or sorry, 19,000. Okay, so F times 0.65 is equal to, so the difference between these two is 2,375. When I subtract the two. Get F by itself, divide both sides by 0.65. And when you get your final answer, 2,375 divided by 0.65. I get my final answer for the force, 3,653.8 newtons. It's a positive answer. You do need to be careful about positive versus negative. If you're doing this part carefully and correctly, you should get the right value. So I ended up more than what I started, which means that I should have a positive force to increase it, not decrease it. Okay? And that's it. All of the problems are going to work this way. Sometimes you might have to solve for like mass or velocity, in which case your P equals mv won't be a number. It'll be like 950 vi, or vf in this case, or maybe 950 vi. Maybe you're solving for delta t, in which case you'd have to get f to the other side, whatever the case may be. You're very rarely, if ever, going to solve for delta P. You're always going to break it into this final minus initial business. Likewise, you won't usually solve for mass, but it does come up on occasion, so just keep that in mind. Okay, questions for me on the problem? Okie dokie. All right, here's what you're going to work on.